Okay, let's talk about solving this equation right here. We have this polynomial equation. It's x to the 6 minus 1 is equal to 0. And at first glance, this looks relatively, manageable, right? And you kind of look at it like, no, I think I can handle this. Well, in fact, this is a fairly sophisticated or difficult problem, and like maybe 1% could solve this. Now, this is not to make anyone out there that's, let's say, in the 99% of people who couldn't solve this at first glance. There's plenty of people in this group that could do this. The people that can really solve this problem, I would say, are people who are actively studying kind of advanced algebra, pre-calculus, etc. Because you need to use some formulas, and this stuff has to be fresh in your brain. And I think the point I want to make here is that you can be excellent at math, but you may have to brush up on, some formulas and some concepts. That's pretty normal, even for people who, math teachers and people with math degrees. You're not going to remember everything. So, I think that's a real big point I want to make here is that just because you don't remember something right off the top of the bat does not mean that you are terrible at mathematics. That's why you have to take great math notes, okay? But if you are one of those people that remember exactly how you could do this problem and do it the way I'm going to show you how to do it, then that's very, very impressive. And if you want to go ahead and pause the video and see what you can come up with here, play around with this thing, that will make this more interesting. I'm going to kind of give you kind of a spoiler alert here. I am going to be doing some pretty complicated math, probably for most of you out there. So if it gets too complex, you know what? Just switch videos. Or if you just kind of want to, see how this thing pans through. But, the main point here I'm going to try to make before it gets started is when it comes to math, okay, you're going to have to go back and brush up on things. So don't feel bad about your current state. It means that you might be just rusty in math. You're going to have to go back and learn some things again. But it'll be interesting to see how many of you out there actually remember what I'm going to go through here. I would say probably that might be like around 1%. Okay, so we're going to get to this in just 1 second. But first, let me quickly introduce myself. My name is John. I'm the founder of TabletClass Math. I'm also a middle and high school math teacher, and over several years, I've constructed what I like to believe is one of the best online math help programs there is. That's a pretty bold statement. Of course, I'll let you be the judge of that. You can check out my math help program by following the link in the description of this video. But basically, I have 100 plus different math courses ranging from pre-algebra, algebra 1 geometry, algebra 2, and pre-calculus. I teach this stuff here in my pre-calculus course. But beyond that, I also have many, many courses in the area of test preparation. So if you're studying for the GED, SAT, ACT, GRE, GMAT, ASVAB, AccuPlacer, CLEP exam, ALEX exam, maybe a teacher certification exam, and many other type of exams, I can help you out because all those exams have math on them. So somebody out there thinks math's pretty important. And if you don't do well in the math section, don't do well on the exam, so I can help you prepare. I also do a lot with homeschooling. So if you homeschool, I have a great homeschool learning program, and then obviously help those of you that are just struggling in your current math courses. Now, one thing that you really have to do if you're truly serious about improving in math or learning math is you got to take great math notes. I mean, you're here to kind of, check out some math, right? So I'm thinking that you might be a student. If you are, listen, you got to do this. I've been teaching mathematics for decades. The one thing I can point to with consistency is those students who take great math notes almost always do very well. And then those students who don't take notes, right, think they can kind of get away with it like I kind of did way back in the 1980s. I thought that, you know what, I could pretend I was taking notes, but in actuality, I was taking notes, but they were to my friends and everything else. I wasn't paying attention, and my grades look like this. So, if you're not doing the right things, you can't be complaining about your current math grades if you're not putting in effort. So take great math notes, and as you improve in your notes, I can actually you can use my notes to study from. So those would include pre-algebra, algebra 1, geometry, algebra 2, and trigonometry. You can find the links to those notes in the description of this video. Now, you're going to see here the importance of note-taking. Even at the more advanced levels, even those students who take excellent notes, it's still very challenging to get top grades, let's say in calculus and more advanced math courses. So this is just absolutely becomes more critical as you progress in your education, not just math, but anything else. So, okay, so we're going to get into this guy right here. And if you think you know how to solve it, go ahead and pause the video and do so. But let's get into what's going on here. All right, so what we have is a polynomial equation. It's a 6th-degree polynomial equation. And I can write x to the 6 minus 1. I can put that 1 on the other side of the equation. So I'm really going to be solving this equation. X to the 6th power is equal to 1. Okay, so this guy right here is a polynomial, and as such, we have this thing called the fundamental theorem of algebra that states that, okay, whatever the degree of the polynomial is, that's how many solutions it's going to have. Okay, now these solutions could be real, they could be imaginary, complex numbers. We just don't know, but for sure, there are 6 solutions. So I say, okay, 6 solutions. So how can I solve this particular equation, x to the 6 is equal to 1? Well, to solve this, I can simply just take the 6th root of both sides. So I would get the 6th root of x to the 6. Another way to see that would be this. Okay, I'm going to raise each side to the 1/6 power, which is effectively the 6th root of both sides. So I get x is equal to 1 to the 1/6, which is the 6th root of 1. So if I can figure this out, then I'll come up with all my solutions. But let's just kind of take a look at, let me kind of erase this here. What would be some obvious solutions? So I'm looking at x to the 6 is equal to 1. Now, some of you might be like, well, 1 and -1 should work, and you would be correct, because 1 to the 6th power, right? 1 to the 6th power, positive 1. 1, 2, 3, 4, 5, 6. Okay, let me see. Well, yeah, I got 6 here, so they're all positive, so the answer is going to be positive 1. So that's a solution. And -1 to the 6th power. Let's write this out. Okay, a lot of little writing here, but I want to make my point here. So -1 times itself 6 times is also a positive 1. Okay, this is positive, positive, positive. This all turns out to be positive. So we know that 1 and -1 are solutions, but remember, the fundamental theorem of algebra says we have 6 solutions. So where are the other solutions? How do we find those guys? Well, that's where this gets interesting. Okay, so what I'm going to get into here is pretty sophisticated math. If, you're kind of like, your expression is like this, you're like, I don't understand, just stick around and gain an appreciation of the things that you have to be, at this level of math, how you have to have your notes and you have to be paying attention, and you got to be detailed, you got to be neat, you got to be structured, because if you don't, you're not going to be able to solve, advanced math problems. So let's get into it now. So what I can do is I can solve this problem by turning 1 into a complex number. Okay, so you're like, whoa, what's that? Well, a complex number, that's that A plus BI business. If you don't know what a complex number is, then this video is probably going to be too complicated for you. Nothing that you can't learn, but it's probably beyond what you're learning right now. But I can turn 1 into a complex number. Then what I'm going to do is take this complex number and write it in its trigonometric form or polar form. Okay, so that's what we're going to do. And if I can do that, then I can use this theorem, and it says the nth roots of complex numbers. So when I have a complex number written in this form, and this is the kind of standard form to write a complex number in trigonometric form, we have n distinct nth roots. In other words, if I want to take this guy to the 1/nth power, we'll be able to find n distinct nth roots. Remember, we're trying to find the 6th roots of 1, and this little equation formula here, or theorem, will allow us to do that. So it's going to be r to the 1n. You can kind of see the rest of it here. Cosine, theta is the angle. Of course, you're getting that angle from your complex number written in trigonometric form. And then 2k pi, I'll talk about what k is here in a second. Now 2 pi right there, this is if we're doing this problem in radians, but this is typically how the equation is written. But if you're working in degrees, and we're going to work in degrees, 2 pi, okay, this right here is the same thing as 360 degrees. All right, so Now, of course, n is the root that you're taking. So for our problem, n is 6 because we're trying to find the 6th roots. And then we're going to get this business here. We're going to calculate this thing out for each one of these. K equals 0, 1, 2, and we're going to go all the way up to n minus 1. Remember, n is 6 because we're trying to find the 6th root. So that would be 6 minus 1 or 5. Okay, so at this stage of the game, if you're like, okay, this is just, crazy stuff. No, I get it. Okay, this is, fairly sophisticated math. But, if you're expecting to progress up to the pre-calculus level and beyond, you're going to have to be able to manage this. So how could you possibly learn this stuff without taking great notes and being completely focused, with what your teacher's saying, asking questions and practicing? So when I'm harping in my videos, if you watched other videos of mine about note taking and focus, I'm trying to get you ready for kind of the big leagues. In more basic math, you can kind of get away with poor study habits, but when you get to this level, there's just no way. Okay, you won't be able to even start the problem. All right, so let's continue on. And in order to use this formula again, we're going to have to figure out, we're going to have to write 1 as a complex number. So remember, the solution to our polynomial equation is the x is the 6th root of 1. Okay, we can also think of it this way. So x is equal to 1 to the 1/6. So we have to find the 6th root of 1, and this is actually called the roots of unity. There's actually a special term for this. So let's get into this, and let's write 1 as a complex number. But we'll write it as a complex number in this form, a plus bi form, and then we'll convert this thing to trigonometric or polar form. Okay, so here we go. So a plus bi is the form of a complex number. A here is our real component, and this is our imaginary component. So we're trying to figure out what 1 is equal to. Well, I got 1 here, plus I don't have any imaginary components, so it's really 1 plus 0i. That is our a plus bi, and I can simplify 1 plus 0i, 0 times I, that just goes away, so this is just 1. Okay, so hopefully don't overthink this, but 1 as a complex number we can write as 1 plus 0i. Okay, so we do need this 0i business because I'm going to go ahead and graph this. Okay, excuse me. 1 on the complex plane. All right, so on a complex plane, the x-axis is the real component, and then the y-axis here is the imaginary component. So you kind of think of this as x, y point, kind of like 1, 0, and that would be located right there, just 1. We only have 1 on the real component. So what is the angle here? Well, there's 0 degrees. In other words, if we had a point right there, okay, that angle might be like 60 degrees. But here, this is just 0 degrees. So our angle is 0 degrees. Our radius is 1. Okay. Now, if you haven't studied this, polar complex numbers and whatnot, don't feel bad about anything in terms of not understanding this. This is fairly complex stuff, especially if you've never studied it before. However, if you have any intention of taking more advanced math, just watch what I'm doing, even though you may not understand the explanations, because you're going to gain an appreciation, or you're going to hopefully get a sense of what to expect. Maybe that's my whole goal here in this video, that you're going to have to do these type of problems. Okay, handle this kind of work. So it is a lot. All right. So if you're thinking about, yeah, one day I'd like to be able to take this level of math. Well, this is kind of some of the stuff you're going to be dealing with. All right. Now, here is 1. Okay. 1 is the same thing as a plus bi. This is the complex form of 1. However, I want to write this a plus bi form as in trigonometric form. So that's the z. Okay, z is just a little variable that we state, that we represent this complex number in trigonometric form. So r is the radius. It's just how far out from the origin. So that's 1. Okay, let's go and write this here. We might be learning a little bit here as well. So if you're picking up on some of this, then that's excellent. And now complex number is always written as cosine the angle, okay, plus I sine that same angle. And we already determined here there is no angle. The angle is 0. Well, there is an angle. It's 0 degrees. So 1 is going to be its radius from 0 out to 1. Cosine 0 degrees plus I sine 0 degrees. So here is our lovely number 1, okay, that we converted to a complex number, a plus bi, which was 1 plus 0i, and then we converted that complex number into a trigonometric form or polar form of that complex number. This is the form we need to use our awesome nth root formula. Okay, so if I have this, then I'm ready to go. So yeah, it's some work to set this up, but now let's get into it. Okay. So what we want to do is find the sixth root of this complex number z, and here is our complex number right here. Okay, this is 1. I'm sorry, this is the trigonometric form of 1. So this is 1, and we're trying to find the 1/6, the sixth root of 1, but we need the trigonometric form, complex trigonometric form of that number. So here it is. Now I can use this formula. All right, so remember, this 2 and this pi, this is typically how this formula is given. Another way I could write this 2k pi is 360 degrees k. All right, so I'll use the 2 pi version when I'm dealing with radians as my angle. But here, I can also write this as 360k. But I wanted to leave that 2k pi in there because this is pretty common. The way this formula is given, okay? So our angle, okay, this is our angle. That's going to be what? 0 degrees, okay? N is going to be the root. We're trying to find the sixth root. So N is 6, okay? This is R. R is 1, okay? That's what this is going to be right there. So this is going to be 1 to the 1/6. Now, when we do this, we're kind of ignore this for this particular problem and just focus on this part to get our solutions. You'll see this here in a second. And let's see, what else do we have? That's pretty much it. No, we have the k, okay? So the k value is the following, okay? So k always starts at 0, and you just keep indexing 0, 1, 2, and you stop at n minus 1, okay? So because we're trying to find the sixth root, that would be 6 minus 1 or 5. So we're gonna have to calculate out 6 different things for k equals 0, 1, 2, 3, 4, and 5. So we're gonna have to calculate this out and do 6 different calculations for each time k is this particular value. Okay. All right. So let's see here. Let's go ahead and get started. So this is the setup. All right. R to the 1/6, okay? This is we already discussed this here. All right, we're just kind of setting this formula up, and then we're going to replace K, all right? Again, we're using the 360 degrees because we are working with degrees, and it is 6. You can kind of study this setup. And then we're going to replace K. Let me scroll down here. We're going to plug in 0 for K, do all this math, get a value, that's going to be one solution, okay? Then we're going to do the same thing. We're going to plug in 1 for k, do the same thing, and then we're going to plug in 2 for k, do the same thing, etc., etc. We're going to go all the way up to 5. And if you notice, we have 1, 2, 3, 4, 5, 6 different results we're going to get. We're going to get 6 answers here. And what do you think those 6 answers are? Those are our 6 solutions that we know, we have for this polynomial equation. And this is it, okay? So if you understand this so far, now this is really just coming down to like a number crunching operation. And let's get into it. I'm not going to do all of them, but I am going to show you how this works. So let's start off with k is 0. So remember, this is where k was at. It was k times 360. So you can notice here I'm plugging in 0 for that k. And what am I going to get? Well, this whole numerator, 0 times 360, that's 0, 0 plus 0. So this whole thing is 0. This whole thing is 0. So I'm going to get cosine 0 degrees plus I sine 0 degrees. Cosine of 0 degrees is 1. Now you can use your calculator. You should just know some of these basic values. And the sine of 0 degrees is 0, so this goes away. And when k was equal to 1, we end up with this simplifying down to 1. Interesting, okay? Remember we said 1 and -1 are solutions? Well, here 1 just popped up, so pretty cool, right? So we expected it, and there it is. All right, now let's move on and do k is equal to 1. All right, so right here in this k spot, I'm going to plug in 1, so I'm going to have 1 times 360, of course, that's 360 plus 0 degrees. That's 360 divided by 6. That's 60 degrees. Okay, we're going to get 60 degrees over here as well. Now, when you simplify these values, okay, typically you're going to want to write your answer in a plus bi form. Now, I could have been more specific about that in terms of finding our roots, but cosine of 60 degrees is 1/2, and the sine of 60 degrees is the square root of 3 over 2. These are basic values that you should know when you're studying trigonometry, but you could find decimal equivalents if you had your calculator. Okay, but the bottom line is, when you simplify this guy, this is what you get. And now this is another root. So now we just found 2 roots. Now, one interesting thing to know is when you find a complex number, okay, as a solution to a polynomial, you expect to see what we call its conjugate. So here I have 1/2 plus I square root of 3 over 2. I'm going to expect to see this conjugate would be the opposite sign. So this would be negative, okay? So I'm looking for that as a root. But what we have to do is continue on. And when you continue this same process, I'm not going to show you, but when we figure out what k is equal to 2, you get this solution. K is equal to 3, boom, you get -1. Remember, we already were from the beginning of this problem, we were looking for 1 and -1 as solutions, and here is -1. It popped up as it, to be expected. And then as I continue on here, for k is equal to 4, all right here, I'm getting the conjugate of k is equal to 2. Notice here, this is plus, this is minus, it's the same thing. So look for conjugate pairs. This is stuff that you learn when you're studying more advanced polynomial equations and whatnot. And then lastly, for k is equal to 5, I get this final root, and this is 1/2 minus I square root of 3 over 2. Guess what? That is the conjugate of this guy up here, okay? And these here are the 6 roots, okay? For 1 to the 6, we have the 6 solutions here, okay? And this is 1, and they're all unique, okay? And that's what this theorem states. Okay, we have 6 distinct roots, okay? And this is our last one right here. But this is fairly sophisticated math, all right? No doubt about it. And even, students that are strong in mathematics, they're going to have to focus and work at getting that. I mean, there's very, very few people in my experience, students that don't have to work hard, so there's nobody out there. Well, there's always exceptions, okay? But, from my experience, for years and years and years and years and years, and I've studied with some pretty smart people taking graduate level mathematics, everybody's got to work hard at it, at whatever level you're at, okay? So don't think that, if math doesn't come easy to you, that, you're not capable of doing mathematics, okay? That's not the case at all right? You're just going to have to work hard at this stuff, and you have to take notes. You're going to have to study. You're going to have to practice and keep working at it. And over time, this stuff will click. Okay. Now, how much time you have to put into it? Of course, that's going to vary with every individual. Some people might pick these things up quicker than others, but it doesn't make a difference. Ultimately, most people can learn this. It's just a matter of how much time and effort you individually have to put into it. But don't be discouraged by, or let's say, what's the word? Intimidated. That's the word I'm looking for. Don't be intimidated by this stuff. This is all things that you can learn, but it is a process, okay? And there's a lot of math you're going to have to kind of build up to. So everything you're learning in math is very, very important. It builds upon itself. So don't think that you can just ignore one skill set, like, yeah, I'll never see this again. You never know, okay? And if you do this, if you forget or you kind of blow off too many of these different things, then your foundation will be too shaky to really handle this kind of level of mathematics, all right? Okay, so let's just kind of end the video there. Again, if you didn't understand any of this, okay, if you were part of the 99%, we're like, I didn't understand anything that was going on, don't be discouraged. You can, okay? Maybe 1% of people remember this formula and how to use it. I doubt even that much, okay? Even myself, right? If I was away from this stuff for a while, I'd have to think about that formula. I couldn't recall that formula. That's not a formula that I would have in my long-term memory. I'd have to go get my notes, brush up, and like, okay, now I know how to apply that particular formula. So don't feel bad if you weren't able to get this right. But if some way you gain a little insight about more advanced mathematics and your ability to learn it, please consider smashing that like button. And if you're new to my YouTube channel, please consider subscribing. I've been on YouTube for 10 plus years, have over 1,000 videos on my channel, basic to advanced math. I do a lot of stuff in more basic algebra and whatnot. So this is kind of, I don't do too many of these type of videos because, there's less people taking more advanced math than there are people taking like Algebra 1. But nevertheless, I try to kind of spread it around and do various levels of mathematics. So hopefully you'll consider subscribing, and please take advantage of the videos I've already posted and the videos I will be posting, okay? But my best math help will be within my math help program if you like my teaching style and you're looking for extra help. All right, so with that being said, I definitely wish you all the best in your mathematics adventures. Thank you for your time and have a great day.